Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 11.1. Yes, we are now going to talk about sequences, and series. That's in fact the entire Chapter 11 stuff that we're going to be doing. So, sequences and series. What does it mean? A sequence is a sequence of numbers with commas and stuff. A series is when you add them up. So here in particular, we got a 1, 2, 3, 4. On this side, we got a 1 plus 2 plus 3 plus 4. That's the only difference. But the patterns that we're going to be seeing are all the same. Let me give you some. 1, 2, 3, 4, 5. I'm going to ask you, can you tell me what the next number is? It's 6. Very good. How did you know? What did you do to get to the next number? Don't just think about it here. What did you do? You added 1 because you saw that each time we were adding 1 each time. There you go. That's the patterns that you're adding 1. Here's another one. 2, 4, 6, 8, 10. What's the next number? 12. Exactly. How did you know? Because I'm adding 2 each time. Plus 2. 1, negative 3, negative 7, negative 11. What's the next number? That one's a little bit more difficult, but if you could see, we're actually subtracting 4. And so here I'm going to subtract 4 and get a negative 15. Here's another one. I got 1, 2, 4, 8, 16. What's the next number? 32. This time we're multiplying by 2. We're doubling it. Each time you see we're doubling it. I did not want to zoom in. It doesn't really matter. And then here's another one. 1, negative 1/3, positive 1/9, negative 1 over 27. What is that next number? Yeah, a little different here. So notice the positive, negative, positive, negative, positive. Also notice that it's the denominator that keeps growing. In fact, what you're doing is you're multiplying by a negative 1/3 each time. You're multiplying by a negative 1/3, so 2 negatives will make a positive, etc., etc. 1 over 81 would be your answer there. Okay, awesome. So, lots of different sequences and series. I was just trying to show you all these cool things that we could do with it. Let's actually do some homework. So we got 11.1.1. It says an is equal to n plus 4. And then they say a1, a2, a3, and they probably got a lot more than that, but I get bored. And so I got a1, n equals 1. So I got basically here 1 plus 4 is equal to 5. I got a 2 plus 4 equals 6. I got a 3 plus 4 equals 7. Etc., etc., etc. 11, 1, 9. I got a sub n is equal to 2n divided by n plus 8. And they want a1, a2, a3. All I'm doing again is plugging it in. I got 2 times 1 divided by 1 plus 8, 2 over 9. I got 2 times the 2, 2 plus the 8, 4 over 10 makes 2/5. I'm not going to keep doing it. You get the idea here. Just plug it in. Let's do something a little different. 11, 1, 13. So I got a1 is equal to 9. And it says an is equal to an minus 1 and then plus 5. This is different. What they're trying to say with this portion is, well, in fact, the whole thing there, is that my current answer is equal to the previous answer plus 5. Previous answer plus 5. And so I'm going to go about my work that way. They say here that a1 is equal to 9, and they're going to ask for a1 in the problem. You're going to put a 9. a2. What you're going to do is use your previous answer to find the current answer. Your previous answer was a 9. You're going to add 5 to it, making 14. A3. How do we do it? Well, again, my previous answer was a 14. Then they say add 5 more to that to make a 19. And you can see that you can actually get all these answers real fast. Like, I think the next one's a 24. And so on and so forth. This is actually called recursive because you keep using the previous answer to get the next one. Cool. 11, 1, 19. My 9s are looking really sloppy today. So I've got n is equal to n cubed divided by n factorial. Now, what the heck is that? That is a factorial. And its notation is with a little explanation mark. Let me give you some examples of what factorials will look like. So let's start with 3 factorial. Let's actually give me a little bit of room here. 3 factorial. Well, that's 3 times 2 times 1, which makes 6. 4 factorial is 4 times 3 times 2 times 1, which makes 24. 5 factorial is 5 times 4 times 3 times 2 times 1. And you can see as we go down this pattern here, I'm just multiplying from that number downwards, multiplying all those numbers together, and we get a number. I think that's a 120. I don't have that on my paper, though. And you can keep going, 6 factorial, 7 factorial, but you're going to get a big number pretty fast. Like, let's go in reverse. What about 2 factorial? Well, that's 2 times 1. It's just simply a 2. What is 1 factorial? A 1. What's 0 factorial? It's actually important. It's not 0. It's a 1. What? How does that a 1? I don't know. I actually recommend going to YouTube. No, I don't recommend YouTube. Not for this one. Go look it up sometime if you're really interested. It's like a big proof of how it works. And that's cool and all, but I don't know if I trust every single mathematician, finger quote, mathematician, that you find on YouTube in particular. Let's keep moving. Sorry, I'm just thinking of all the inaccuracies that could happen. But it's okay. Wikipedia is way good, though. So I actually do like Wikipedia. So what I'm going to do here on this particular problem is just plug in n. They say find a1, so I'm going to do a 1 cubed and a 1 factorial. Good thing I got 1. 1 times 1 times 1 is 1, and then 1 factorial is a 1. 1 over 1 is a 1. I got a 2. Plugging in a 2. 2 cubed. 2 factorial. So then I got 8 divided by 2 times 1 is a 2 to make a 4. A cubed. So now I got, not a cubed, I'm sorry, a3. A3, I got 3 cubed, 3 factorial. So that's going to be 27 divided by 3 factorial. We just found it was a 6. Oh yeah, it's a fraction, 9 halves. Okay, there you go. So on and so on, continuing on. It's not a hard problem. Can you do these factorials in Desmos? The answer is yes. Let's just go real quick. And so you could use a graphing calculator. Last time we did the matrix one. I'm going to go just to the basic scientific. And what you could do here is say like 4 factorial. Notice all I did was 4 and then an exclamation mark. 5 factorial. What about 100 factorial? Whoa, 100 factorial. Oh, it actually worked, kind of. Look at that. That's a lot. Is that like the amount of atoms in the universe or something? I don't know, something crazy like that. 10,000 factorial. Haha, exactly. Eventually we had to break it. It's just fun to kind of try those things. Next question. 11, 1, 23. I have 5 factorial divided by 3 factorial, and they say find out what that answer is. Now, this is a very simple thing to do in Desmos, yes. So let me actually show you what that would look like. I got the 5 factorial divided by 3 factorial, and there's your answer. You're done. It's not hard to do this. And again, I'm pushing Desmos a lot right now because, well, it's okay to do that. Even the scientific, which basically you could have used forever, I still want to use it as much as I can right now. 20 is your answer, but I want to do this by hand because of the next problem, and I'll show you why. This is a 5 times a 4 times a 3 times a 2 times a 1. And in the bottom, we got a 3 times a 2 times a 1, and you can see that these all cancel. It leaves 5 times 4, makes a 20. But now what I want to do is, with the next problem, I have to do it by hand. And I'll show you why. It's 9n plus 1 factorial divided by 9n factorial, just like this. I actually have to write this out by hand to be able to figure this thing out. So I'm going to start with the 9n plus 1, and then I remove a 1. I minus 1 from that, and then I minus 1 again, and then I minus 1 from that. Why am I minusing the 1 every time? If you go back, what's the difference between these guys? 5 to 4. What did you do? You minused 1 from it, and then you minused 1 from it. And that's what you're doing. So I'm doing the same thing here. And on the bottom, we got the 9n. We start with that number, and then I minus 1 from it, and then I minus 1 from it, and so on and so forth. Notice that these guys all cancel, leaving behind this one, and we're done. Now, hold on, because I have to do another. I have another right here, another randomization. Sometimes it's easy, sometimes it's not as easy. This one is not as easy. We've got to talk about it. I actually have it written down, so it's very important to do. Same style, I'm going to continue to remove 1 from everything I see in the numerator there. In the denominator, same thing. I start with that number, and I start removing 1, and so on, all the way down. Cool. Well, these cancel, those cancel, all these will cancel. Everything cancels except for the 3n plus the 2 and the 3n plus the 1. Sadly, they need you to keep simplifying. If you put this in right here, it's going to say, no, you're wrong, and you're not wrong. And so what do? We FOIL this thing out. And so we got 9n squared plus 9n, actually 9n, and then plus 2. I'm not going to do that for you. You see what I'm supposed to be doing. It's not hard. Just wanted to show you. So that's all sequences and stuff. Now let's talk about series. I got 11, 1, 29. They start with this problem here where I have this big E looking thing and a 6 and a J equals 1 and then a 3J. Now that's not an E. That's actually a capital sigma. That's a capital sigma. It means sum, like summation. Add it all up, that kind of thing. You're adding. And so, funny thing though, I always say this whenever I come to this question. I know you've seen this kind of stuff on like people's T-shirts and stuff before. They're like, yeah, I know Greek. Yeah, it's actually grsk because it's a sigma. That's a capital S, basically, capital sum. So it's grsk, and you can laugh at them now. And if you own that shirt, you can burn it. So, I'm just playing. What are we supposed to do with this thing? Basically, I'm going to plug in the 1, I'm going to plug in a 2, I'm going to plug in a 3, a 4, a 5, and finally the 6 is where I end. I add them all up. So it's a sigma. You add, and then you're done. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. Here, I don't like that. Put a big old plus sign. I'm so biased today. Put a big old plus sign between them, and here we go. Well, I need to find out what those numbers are first. So I got a 3, 6, 9, 12, 15, 18. Add those all up. You can go to Desmos or wherever, and I got a 63. So there you go. As I continue, and I think you saw that up there, I'm going to start doing that symbol because doing this is particularly tough for me. They're the same thing. I'm just, shorthanding it, I guess. So here we go again. 11, 1, 33. I have another big sigma. and I have a 4 is where I'm going to end. I'm going to start at 1, and my formula is I times I plus 4. So same as last time, I'm going to plug into 1, plug into 2, plug into 3, plug into 4, and then we're done. So I got a 1 times 1 plus 4. I got a 2 times 2 plus 4. I got a 3 times 3 plus 4. I got a 4 times 4 plus 4, and then we're done. Big old plus sign. Call it a day. So if I go and find all these numbers, that's 1 times 5 is 5. I got 2 times 6 is 12. I got 3 times the 12. No, 7. Sorry, that's 7. 3 times 7 is 21. And then I've got 4 times 8 is 32, I believe. Doing the math here. Yep. Put a big old plus sign there, and I got a 70. So there you go. Cool. Oh, wow, there's so many of these. 11, 1, 37. So I've got summation I equals 4 to 9 of 8. Oh, okay. This one's an easy one. I'm trying to plug in a 4, but I can't. I can't plug in a 4, 5, or 9, nothing. I can't plug in anything, but I still have to go down the sequence. And so then I have 8 whenever it was equal to 4, 8 whenever it was equal to 5, 8 whenever it was equal to 6, equal to 7, equal to 8, equal to 9. And I add them all up. What is that? 6 times 8 is 48. There you go. I wonder, can some of this here be done in Desmos? Like, even like this guy in particular. I wonder. Let's try it real quick if that's okay. Do they have like a summation function here? No? Can I type sum? Ooh, did you see that? Sum. I typed S-U-M and it popped up. Let's do that previous problem that we were doing. So 1 to 4 of the I and I plus 4 kind of thing. So I got 1 to the 4. And I can't use an I. If you notice, that's an N right there. So I'm going to say N times N plus 4. Oh, feature is not accepted in the current calculator. You know what? It looks really pretty, though. Do you know how to get around this? And again, this is being recorded. Hopefully this will work. I want to see if I can get that answer in Desmos somehow. Let's go back to the graphing calculator for just a minute. We don't really do this graphing calculator very much, at least back in the past. Now we can. SUM, same thing, 1 to 4, N plus, what was it again? Sorry, I missed it. 4. A lot of 4s. Boom! There's the answer. Can you use Desmos? Yes. Yes, you can. Okay, awesome. So let's keep going. So the next one here is 11, 1, 41. And I've got summation of I equals 3 to 7 of I factorial divided by I minus 2 and then factorial. That's a lot of factorials. And so what I'm going to do here is say 3 factorial divided by 3 minus 2 factorial plus 4 factorial divided by 4 minus 2 factorial plus. And then you got the 5. And then you got the 6. And then you got the 7. And then you add them all up. And oh my goodness, it takes forever. Surely there's a way to make Desmos work. So I'm going to just do the same thing here. I'll start over from the very beginning. SUM to make sum. I'm starting at 3 going to 7. And then what I have is, again, n, not I. I don't have an I. I use an n. N factorial divided by n minus 2 factorial. Boom. It's done. It's done. 110. And you can see why I'm trying to utilize your time and my time to be able to get these answers correct the first time. Okay. 11, 1, 43. This time they give me a series, and it looks like this. 1 squared, 2 squared, 3 squared, 9 squared, all the way out to 9. And they give me I equals 1, and they'd say I have to end somewhere, and I got a big old box. So, let's do this thing. I'm supposed to go from 1 all the way to 9. So far, so good. But what am I doing each time? See, I'm using an I, right? So it's going to be an I, and something's going to happen in the I. Well, it's 1 squared, 2 squared, 3 squared, I squared. That's it. You type those in, you're done. That was it. That was it. There's nothing else to do. Isn't that cool? You can go and find out what that is. I don't think they care. Next one, I got 1/2, 2/3, 3/4. Continuing down to 11 over 11 plus 1. And they say, they don't care about the actual value. They say this is a sigma. We start at something to something of something. Okay. They're cheating a little bit by showing you the +1, but that's a good thing for us because we like to see all that information. And they say in the words, blah, 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 you got to start with I equals 1. And so you're forced to type this guy in there. There's nothing else you can do. Everything else will be wrong. So I don't know why they made you type it again, but whatever. Notice if I had here, this is I equals 1. I'm starting here at 1. It looks like it's the numerator number. 2, 3, all the way to 11. 11 is where I'm stopping. And just put the 11. Don't put I equals 11. Just put 11. Now, I actually need to find the formula. Notice that I is in the top. But now what's in the bottom? Well, it's always 1 more than the top. And it clearly shows that right here. I plus 1. I plus 1. That's your formula. That's your answer. This is what you type. And you're done. Here's a weird problem. 11, 1, 61. They have summation I equals 1 to 5 of box squared minus 9 equals box. And actually, I don't know why they have a box right there. I think I boxed it. Normally, I don't do that. Okay, sorry. Hold on. It's not a box here. Whenever I see a box, I think, oh, obviously they're wanting me to fill that in. They have a C sub I, but I'm still going to circle it. This guy is a little different here. That C sub I is the height of the graph that they're going to give you. And they have a graph over here with some dots that look like this. And this is like CN or something. There might be a B graph as well. Just ignore that. You don't need that. You're looking at the heights. And the heights here are 4, 2, 0, -2, and then here -4. And so you want the heights. Here we go. 4 squared minus 9, 2 squared minus 9, just going down this list here, 0 squared minus 9, -2 all squared minus 9, and then -4 all squared minus the 9. You add them all up and you get an answer. Now this took me a second to go and do, but it's not hard. 16 minus 9, 4 minus 9, blah, blah, blah. You get a -5 at the end. Okay, I have one more problem, and it's a word problem. So 11, 1, 69. I got 1/7 summation of I equals 1 to 7 of AI equals box. And then they have this big chart here on the side of all these numbers. Oh my goodness, I'm going to run out of room. And they keep going up. Let me list them. 3.6, 3.9, 4.4, 4.9, 5.3, 6.1. Apparently I was running out of paper room too. And 6.2. My boxes got really narrow near the end. They're saying find out what this would be. And I'm kind of confused. Well, this is a sum. This is an add it all up. and then multiply by 1/7 in the front, it's actually going to make it an average. And so what you're finding is the average height of all these guys. And so what it does is 1/7 in the front, and you're going to take each one of these, and you're going to add them all up on the inside, divide by 7. Oop, that's a 2, not a 3. Okay. And you do the math. And I got here 4.91428, which rounded is 4.9. Okay, I apparently zoomed in again. There you go. 4.9, cool. And you're going to click average hours, because again, I told you it was the average. Now, for part B, they say that AN is equal to 0.5N plus 3. And they want you to do the same thing again, this 1/7 summation stuff of AN. And so what we're going to do is plug in a 1, 2, 3, 4, all the way to 7, and get our values. So times 1 plus the 3, times 2, 3, all the way down to the 7. You're going to add all these up, and you get a total. And then you're going to take that total, and you're going to divide it by 7, or you could say 1/7 times the total. And that is how you get your new average. Comes out to be a 5. Yeah, just 5. Lastly, part C, they're going to want to compare. Notice that we had a 4.9. This time we had a 5. And so this guy here overestimates. That's one of the answers. By 0.1. And how did I get that? 5 minus the 4.9 is equal to the 0.1. Whew! That was like a roller coaster ride. All right. Thank you very much. Have a great day.